Hello, welcome back to another video. In the last video, we talked about recursive formulas for sequences, which were in a way a little bit harder than the other formulas. That's the only thing, as far as I know, that we're going to be doing with recursive formulas. You will find that writing recursive formulas is actually much easier than what we're about to do in this video, where we're going to be writing the formula for a sequence for the nth term of the sequence. So let's say I have a sequence here, and we've got like 1/2 is our first term, 3/4 is our second term, 5/6 is our third term, 7/8 is our next, and it just keeps going like this, okay? So real fast, before we do anything more with this, okay? Let's just figure out what is the next term in this sequence. What's the pattern that's going on here? Well, it appears every time the top number is going up by 2, right? I start 1, 3, 5, 7, right? Each one I'm going up by 2. The top and bottom number, it looks like, are always 1 apart, right? So the next term in this sequence would be, I would go 2 more on top, so 9, and then 1 more than that on the bottom, so 9/10 would be the next term, and it just keeps going from there, right? So the next one after that would be 11/12, and so on, okay? So whenever you get like a sequence, normally your first step here is you want to figure out, well, what's the pattern here? What's happening? Could I predict the next couple terms in the sequence? And well, yes, we can, right? There's kind of a pattern here of we go from 1 to 3, and then 3 to 5, and then 5 to 7. Each time those are going up by 2, the tops at least. Those are all going up by 2, okay? So the next one should also go up by 2 to give me 9. And then I've also noticed the top and bottom are always 1 apart. The bottom one's always 1 smaller than the bottom is always 1 bigger than the top. And so that's how I got this term here, okay? Now, not all patterns are like this. Some patterns will be different, okay? But you kind of want to notice the pattern so that you can write an equation for it, okay? So, what we want to do here is what we're going to do is write a formula for the nth term. So let's say that I have n, right? Some natural number. It can be any natural number I want. I want to be able to write a formula with n in it so that I can find the nth term of this sequence, right? So this is your first term, right? When n is 1. Let's use a different color. So 1/2 is when n equals 1. This is when n equals 2. This is when n equals 3, and so on, okay? So we want to write a formula that will give me these things when I plug n in, okay? Well, the first thing you kind of want to notice is, well, the top is going up by 2 every time, right? And so it's going to be linear, okay? And so you know the slope of your line is going to be 2, so you know you're going to have like a 2n, like, because mx plus b, right? M is your slope, right? You're going to have a 2n, and then plus or minus some number here. So there's going to be something else that comes over here. And I'm not sure what it is yet, but let's try plugging in like 1 for n and what I have. When I plug in 1 for n, I get 2. And that's not quite right. For the top, I need to get 1. So from 2 to get to 1, I would just subtract 1 from 2 to get me the 1 that's in the top. I haven't dealt with the bottom yet. Let's just focus on the top first of how do we get this 1, 3, 5, 7, and 9. Well, it seems like if I do 2 times the number and then minus 1, that at least works on the first one. Let's try on the second one. When I plug in n equals 2, what do I get? I get 2 times 2 is 4, minus 1 is 3, which is what I wanted it to be. Okay? And then let's try 3. When I do 2 times 3 is 6, minus 1 is 5. Okay? N equals 4, we get 2 times 4 is 8, minus 1 is 7. So we've got the right formula for the top of my fraction. Okay? So this will give me the top of my sequence. Now I just need to get the bottom. Well, you'll notice the bottom is just 1 more than the top. So if I take this and add 1 to it, okay, so I do 2n minus 1, and then I would add 1 to that, because the bottom is always 1 more than the top, okay, I would get 2n minus 1 divided by 2n. Okay, let's try this and see if it works. Okay, so when n is 1, let's plug it into this formula, the 2n minus 1 over 2n. Okay, when I plug in n, what do I get? N equals 1. We get 2 times 1 is 2, minus 1 is 1, and then 2 times 1 is 2. So 1 divided by 2. Okay, so that works. Let's do 2. So we get 2 times 2 is 4, minus 1 is 3, and then 2 times 2 is 4. Okay, so that works, right? 3/4 matches. 3, when we plug that in, we do 2 times 3 minus 1. That's going to be 6 minus 1 is 5. Divided by 2 times 3 is 6. So 5, 6. Oh, 5 over 6. Okay, and again, that works. So it seems like this is working, right? This is the right formula for the a sub n. Okay. I'm going to do one more example of this to kind of give you another kind of helpful example here. But this is the right formula. This would be our final answer for this one. So it's 2n minus 1 over 2n. That would be my a sub n in this case. Okay. I'm going to maybe get a blank one for my new problem. Okay, so let's suppose I've got another sequence. This sequence is -2, 4, -8, 16, negative 32, and so on. Okay. And again, we're going to try and write the formula. Write the formula for the nth term. Okay. Well, how do we do this? We first want to look at the pattern here. Okay. So it starts at negative 2 and then goes to negative 4. Okay, or sorry, positive 4. Okay. Then it switches to negative 8. Then positive 16. So you'll notice kind of there's a negative every other term in this, right? Every other term, it looks like, is negative. It keeps kind of flipping back and forth between negative and positive, okay? And then what is happening with these other numbers? Well, there's 2, 4, 8, 16, 32. What's happening here? Well, I'm adding 2 and then adding 4, so I'm not adding the same amount. But what about multiplying? If I double the 2, I get 4. Double the 4, I get 8. Double the 8, I get 16. Double the 16, I get 32. So these numbers are doubling, right? To get between these guys, you are doubling. Okay? So that looks like kind of what's going on with this sequence is we're doubling our numbers and switching the sign. So the next term in this sequence is we double 32 to get 64, and it would be positive because the 32 was negative, right? We're just alternating signs back and forth. Okay? So to find a formula for the nth term, what we're going to be doing is looking at, well, so a sub n should equal, since we're timesing by 2 repeatedly, it's going to be an exponential function. When you're adding things repeatedly, that's going to be linear, okay? So where we're timesing by 2 repeatedly, it's going to be exponential, and it's going to be something like 2 to the n. Okay, because I'm timesing by 2 repeatedly. Let's see if this works. Well, when I plug in 1, I get 2 to the 1 is 2, so that lines up. It's not the right sign, but we'll deal with that in a second. When I plug in 2, I get 2 raised to the 2 power is 4. Good. 2 raised to the 3rd power. What happens when I do 2 cubed? That's 8. 2 raised to the 4th power is 16. So this is the right formula for at least this part without the negatives that keep alternating back and forth. Okay, so that will give you the right numbers here. And so to deal with the negatives alternating back and forth, this is kind of a trick that you can use to help with these, is whenever you want negatives to alternate back and forth, you can just throw in a -1 to the n, or to like the n-1 power sometimes. Notice what happens when you do -1 to the 1 power. That is -1. What happens when you do -1 to the 2 power? You get +1, right? What happens when you do -1 to the 3rd power? You get -1 what happens when you do -1 to the 4th power? You have 4 negatives times each other, which is going to be +1. So notice when you do this, the -1 to the n power, it alternates between negative and positive depending on when n is even or odd, right? And so this will give me the right sign to go in front of these terms of this sequence. -1 to the n will alternate the signs, so it'll match up here. When I plug in n equals 1, I get -1 times 2 to the 1, so -2, which is what I wanted to have happen. When I plug in 2, I get +1 times 2 squared, which is 4, so +4. And this works, okay? So my a sub n for this one would be -1 to the n times 2 to the n, okay? Again, where it's multiplying by the same thing every time, that's why you kind of expect it to be exponential in nature, okay? So hopefully that helps. You got a few homework problems like this. In the next video, we're going to look at sums of sequences, and we'll kind of go from there.